Well, hello again. We're going to do some more back to basics style problems involving exponents. Look at these wacky problems. I'm going to start this by going a little out of order. I'm actually going to go right to left instead of left to right. I'm not happy with the order in which I did these problems. Let's start as easy as possible. And then maybe we'll run into a shortcut or two. I don't know. 3 squared. What's 3 squared? 3 squared is 3 times 3. And then there's a big times dot in the middle there, so I'm going to leave that there. And then I have 3 squared again. Let me choose a different color. 3 times 3. Okay, so I know from the previous video, 3 times 3 times 3 times 3 is just 3 to the 4th. Okay. So there's got to be a way I can get that 2 and that 2 to a 4th. I don't know. Times, add? I don't know. We'll see. Let me look at those 8s there. Ugh. So many. That one has 10 of them. So 8 times 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 8. 1, 2, 3, 4, 5, 6, 7, 8 eighths. Times, we'll put one over there, times 8. That one has 4 eighths, so times 8 times 8 times 8 times 8. Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so 8 to the 14th. Huh. So I wonder if there's a way I can get that 10 to the 4th and 10, or that 8 to the 10th and 8 to the 4th and get that 10 and that 4 to a 14. I don't know. Maybe. I don't know. Third power. What's taken to the third power? 5 to the 4th times 5 to the 4th times 5 to the 4th. Okay. So each parentheses is going to be 5 times 5 times 5 times 5. 5 times 5 times 5 times 5. 5 times 5 times 5 times 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 5 to the 12th. All right, hold up. No way. No way. Let's go right to left again. I went from 3 squared times 3 squared, and that became 3 to the 4th. Why? When I multiply two numbers of the same base, I add the exponents. When I multiply two numbers of the same base, I add to the exponents. 2 plus 2 is 4. That becomes 3 to the 4th. So when I add two or multiply two numbers of the same base, I add the exponents. 10 plus 4 is 14. However, when I take a power and throw parentheses around that and take that to another power, I multiply exponents. All right, so let's see if we can remember those rules without having to write all this mess again. That's too much. Here we are. Okay, so if I have a power taken to another power, I multiply exponents. The last thing I want to do is write out parentheses, parentheses, parentheses. B, 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 12 times. B, 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 12 times. B, 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 12 times. Just think of it this way. You have 3 groups of 12 B's. 3 groups of 12 is 36, so I would have 36 B's. If I were to write out 6 H's and write out 1 H next to it, I would have 7 H's. In other words, add the exponents. When a power is being multiplied to a power, add the exponents. When a parentheses is being taken to the fifth power, I write that parentheses out 5 times. I would write that parentheses out 7 more times. So I would write out -4, -4, -4, -4, -4, -4, -4, -4, -4, -4, -4, which is 12 -4s, or 5 plus 7. So I would write out parentheses -4 to the 12th. That's the shortcut. A power to the power means you multiply. When you multiply powers, you add the exponents. Okay, let's do more. When I multiply 2 powers, I add the exponents. So I have 2 2/3 next to 6 2/3, so that's going to give me 8 2/3. Since I have 5 parentheses living in this parentheses, and I have 2 groups of it, I'm going to multiply exponents. So if you're looking at that and you're like, that's confusing looking, just pretend that little parentheses is an x. So if you had something like x to the 5th squared, you would just be like, multiply the exponents. This is no different. Instead of x, you have parentheses 3/4, and then you multiply the exponents. And then you multiply the exponents. Okay. This is different. Usually I'm just given one thing, but let's see if we can figure this out. Simplify the expression means we actually have to do the math. Great. So what this is I have 3 bags, and each bag I have $6 and a giraffe. $6 and a giraffe. $6 and a giraffe. So I have 6 times G, 6 times G, 6 times G. Or I could just write it out like this. If I have 6 times G times 6 times G times 6 times G, I could just write out 6. I don't even need the parentheses. I'm getting rid of that parentheses right there. I could just write out 6, 6, and 6. 6 times 6 times 6 times G times G times G. Wait a minute. That's just 6 to the 3rd times G to the 3rd. Wait, so I didn't have to do all that mess. All I had to do was kind of do like a little version of distributive property and attach 3 to both of those things. What's 6 times 6 times 6? Where's my phone? Where's Siri? Where is she? What's 6 times 6 times 6?
One moment. Working on that.
So 198.
Something went wrong. Please try.
What's 6 times 6 times 6? I think it's 198. I think it's 198.
Just a sec.
Oh my goodness gracious me.
Working on that.
It's 216. I was way off. G to the 3rd. Now the reason why I'm writing out 6 times 6 times 6 is 216 is this says simplify the expression. The directions in the last couple problems said write your answer as a power. This didn't, so I actually had to do the math. Okay? This is the same thing as saying parentheses times a parentheses, but what I just learned is if I have a parentheses and it's being taken to a second power, I just apply that power to everything. So I get 1 to the 5th squared and k squared. 1 to the 5th, or 1/5 rather, times 1/5 is 1 times 1 on the top, 5 times 5 on the bottom, and then you have k squared on the bottom. Apply that 3 to everything. So that's the same as -3/4 to the 3rd and p to the 3rd. -3/4 is going to mean there's 3 things here. Negative times a negative times a negative, which gives you a negative. 3 times 3 is 9, times 3 is 27, so that's me multiplying the top. 4 times 4 is 16, times 4 is 64, that's me multiplying the bottom. And then p to the third. I have 12 bags, and in each bag I have a rabbit and a turtle. I dump them all out on the floor, and so I have 12 rabbits and 12 turtles. And I like turtles, and I like exponents. And I am done. Bye!